And we are live with our 49th episode of Absolute AppSec. I'm Ken Johnson at CK Tricky on Twitter, joined by my co-host at Seth Law. Seth Law at Seth Law on Twitter.
Oh, you're having problems. You're having problems with the introductions lately, Ken. Gosh, what's going on here? We still need some theme music or something else. Welcome once again to Absolute AppSec. Ken and I are happy to have you. As you may or may not notice, we don't have a special guest today. That is by design. At times, Ken and I just want to talk about current ongoings and industry stuffs, I guess, right? Apps, application security related. The biggest thing that we wanted to kick off with is that both Ken and I will be at OWASP Global in Tel Aviv in May. We are giving our secure code review course once again. So we're excited to get over there and meet all of the OWASP people in the Middle East or in Europe. Should be fun. But watch for signups or anything like that if you're interested. We'll probably also be releasing some other content online around that on how to conduct secure code reviews and kind of cheat sheets. We've been developing kind of a cheat sheet series of different frameworks and languages and how to approach them from a secure code perspective. Other than that, I don't think there's a lot else that's on our plate coming up for travel-wise outside of the normal podcast stuff. Ken, is there anything else?
No, Local Moco Sec in a month, which I need to. Wow, I really need to book travel for that. I did buy the ticket, so that's something. But so yeah, I'm actually going to bring the whole family out for Local Moco Sec, as a matter of fact. But no, yeah, you're right. We've got Tel Aviv in May. I think you and I are pondering the idea of submitting training for DerbyCon.
Obviously, we're not at RSA this week, right? Otherwise, we'd be reporting from sunny San Francisco or, from the vendor floor, I guess, in San Francisco.
Oh my God! Yeah. Well,
we have opinions about RSA. I'm pretty sure. So.
Look, I get it. There's a business. That's the thing. It's the business. All right. Or there are businesses to this industry, and that's where it occurs. Is it somewhere you'll catch me? No, not really. But I get it.
That was very political. There is business, and that is where business occurs.
I don't know.
Thanks for the description of RSA there.
Okay, well, here's what I. Yes, well, for one, I've spoken.
Okay, so maybe we're a little punchy today. It's been a long.
Yeah, I'm definitely.
So,
dude, I'm how I feel. I'm super salty today, so you're gonna get some pretty raw shit from me. So, anyways,
and marking the episode as explicit. There we go. Okay.
All right. Well, now we don't have to worry about it. Yeah. So I spoke at RSA, and that was a good. That was an experience, and met some folks there. And but it's not me saying this. I did think it was interesting that Jeremiah Grossman pointed out on Twitter that you can purchase keynotes at RSA through sponsorships of like $250,000.
Yeah, that's right. And that just came out recently, right? It was just listed on the RSA conference website. You're like one of those platinum or gold sponsors, and they'll give you speaking slots and like premier speaking slots. Like they'll represent you as a keynote. Has nothing to do with the content, has nothing to do with, obviously as an organization, you'd want to put somebody up there that could speak well, but it does feel a little snake oilish, right?
Yeah. For $250,000, you can come on the podcast. Kidding. Kidding.
Well, definitely. I have no problem with that.
Oh yeah. No, I think it was interesting that you pointed that out. I think it was I don't know that that we I mean, I think it's important that people know that's what they're getting into when they go there. Is like there's that aspect to it. So I'm not trying to crap on the whole conference or anything like that, but it's, you know, you got to know what you're getting into. You have to know what you're going there for.
Yeah,
it is what it is.
Right, like most security conferences, like security research conferences that we go to, right? The guys that show up are in t-shirts. I mean, you think about AppSec California, right? Everybody's there in t-shirt, shorts, and flip-flops. I mean, yes, they're all tech t-shirts, right? But it's very much a like technical conference. Even the speakers is pretty lax. You show up at RSA and everyone's got a blazer, and you know, it's definitely more of a salesperson business conference. Even though they do have the talks and there's kind of the research side to it, it is more geared towards businesses that are picking out security products. That's just what it is. It's not necessarily a bad thing, but yeah, it can be tiring for those of us that are on the technical side. I'm trying to be political, apparently. So,
hey, so all the money that's being spent on these products, are we getting more secure?
No, right? So, I mean, we're still in jobs. No, like, oh, okay, yes, like probably we are. Like, there's definitely classes of vulnerabilities that some of those products fix. The interesting thing to do at RSA is to get one of those expo passes, and they hand them out like candy, and just to go walk the floor, because they've got like their 2 or 3 rows, like startup rows, where the organizations or the companies that are there, you know, 95% of those are not there the next year, or they've been acquired by somebody else bigger. It's like, it's very much they splash their cash for that booth, and then they see what happens, right? So I know that people can make business deals there, but I don't know. It's where we get all the security, you know, hot words or whatever you want to call, right? Like
yeah, the thing I'll say about that, because now that you mentioned the startup, the startup set of booths, there were a few companies. God, I can't speak. There were a few companies that had some pretty cool products, but one stuck out in my mind because I didn't even know it was like it makes sense, but I didn't even know it was an emerging area, which was like, I think it was, I have the pen here somewhere. It was like D-Drone, I think, which is anti-drone technology to basically like, yeah,
shoot down drones.
Yeah. Which is kind of funny, because after like that whole thing about using drones to deliver drugs to inside prison walls had come out after I had met or, you know, been introduced to that company and like what they do. And I thought it was, anyways, I thought it was really interesting that they actually had this issue where like and it makes sense, right? You don't want drones getting into secure areas and potentially stealing IP, figuring out the lay of the land security-wise, security controls of a physical building, things like that. Like, it was cool for that. So,
yeah, I mean, you will find the diamonds in the rough there for sure. Yeah, but neither of us are there, so
yeah,
it is definitely a once every few years thing for me. That being said, B-Sides San Francisco just happened, and it looks like there was a bunch of awesome content that came out of that. Asta, who's been on the podcast, apparently I can't talk today either. It was one of the organizers
hot takes and gibberish.
Hot takes and gibberish. Pretty soon we're going to start throwing in like Southern like accents and, you know, other things, but yeah. So Asta was on the podcast. They've been posting quite a bit. Like, it looks like there were some really interesting talks. I know Jerry spoke. Who else was there? I can't remember. There was 3 or 4 different talks. So I'm excited to see some of the content that comes out of B-Side San Francisco. That's usually the day before, the couple days before RSA. They don't overlap too much with the RSA conferences that's going on, but there is definitely a place that you can go and technical content that you can get that would be more up our alley, I guess.
Yeah, there is a DNS SSRF rebinding safeguard talk. I'm trying to find the link. I don't know. Like, apparently I've been tweeting a lot because I can't see where I tweeted it, but I did that. You ever just retweet stuff because you want to like
read it later? Yeah.
Yeah.
Yep, I do. And then I have to go back through and figure out, wait, I can't retweet Ken's memes too much otherwise, or David Corsi's memes. Otherwise it burns me.
David does have the most, yeah, you're right. He does have the dankest of memes. No, it was Clint Gilbert who tweeted saying it was a great talk by Dylan A-Ray and Christian at B-Sides SF on the impact of XSS CSRF DNS rebinding when targeting internal services, which I thought was, given like the fact that we've talked about that quite a bit, and like it's legitimately one of the big issues we're facing now with like distributed architecture and allowing users to make requests to different apps. Like, I don't know. I really want to see it. So hopefully it's streamed or accessible.
So, I've got a question around that, like kind of AppSec minity. I know we're going to go on into the OAuth stuff here shortly. As kind of GitHub, as you're approaching that DNS, SSRF, like vulnerability, right? So like those of us that use Burp Collaborator, right? DNS exfiltration comes across quite a bit, or that DNS external service interaction, which is part of DNS like SSRF. What is kind of the worst thing that you've seen happen with that internally at your work or even anywhere else? Like SSRF is pretty easy because we can usually look up, some sort of credentials off of AWS if they are there. That's a very understandable vulnerability. But when you get to the DNS portion, I'm always like, okay, how do I represent this to people? Like, why should they care about
it? In terms of DNS, I'm not sure if I've seen that actually become something that's exploitable yet. The one thing I did think was interesting was like, instead of supplying an IP or like a host name in the way that you would expect, and this is like, there's blog posts about this, was using, I think it was like a hex version of the IP, and that bypassed our filters. I mean, obviously fixed now, but that was it's pretty rough because you think you're blocking all of the various schemas that people could use, and then they throw something like that at you, and it bypasses your protections, and it's clever. And but yeah, I mean, I guess the worst thing would be if you could convince the SSRF target to make requests internally, and you've blocked internal addresses, and they did that because they poisoned the cache, and it thinks like some website.com is actually pointing to one of your internal services. So that would be damaging. I don't know how often that happens, but I know for like Segment, when we had them on, that's certainly an issue, and I just think it's very interesting.
Yeah.
So
no, and there was actually something else that popped up recently in one of the one of the contracts that I've got that I'm working with people on, and we're talking about subdomain takeovers, right? And I know from a bug bounty perspective, you guys run into that, but I'm also interested on the flip side, right? With GitHub Pages, the way that that's actually set up, we've got this whole concept of kind of dangling CNAMEs.
Oh yeah,
DNS guys put it to me, but like as a service that provides like a front end to like thousands and thousands of people, right? If not tens or hundreds of thousands, like what is your risk profile? Obviously, the risk is not to GitHub.com or GitHub at that point. It's to the people that are pointing at GitHub, and then they like delete the page or whatever it is. So you've got kind of this dangling issue that's out there. Is there anything that you guys do as a service to kind of help prevent that from happening? Or is that just hands off? If you do this, that's the danger of using a third-party service.
Yeah, I mean, so That's a good question. And man, that is
loaded. I realize that it's loaded, and you may not have a full answer on it.
Oh, I have a full answer.
Okay. All right.
Oh yeah, no. And it is loaded. Where to begin? So, firstly, it definitely happens where people have pointed their DNS server at us and then removed like the whatever repo it was. Because the way it works, for those that don't know, is if you set up a Pages site using a GitHub repo, you've got a CNAME, and you put that CNAME inside the repo. And if your DNS server is pointed at us, your CNAME declaration is going to mean that, you know, Seth.redpoint.com or something like that is, you know, we're going to be able to resolve the two, because your DNS server is saying if you go to Seth.redpoint.com, then you need to look at GitHub's DNS servers, and because you put your CNAME inside of our repo, like we do that resolution. So cool, like that's great. One thing we explicitly call out in the documentation is to not do star.github.com, for instance, right? Like don't do that. Or sorry, star.redpoint.com. So don't do like a wildcard subdomain that says any DNS request to this goes to GitHub, because obviously then anyone can start claiming subdomains of your domain. So that's documented. We give people that advice. Now, what you brought up is a good point, and something that we're grappling with now, actually, or we're thinking of, I think we're thinking more about is it's a known thing that if you do that pointing, you know, Seth.redpoint.com at our servers, but then you remove that repo and that CNAME's up for grabs, someone else could potentially claim it, and that's, you know, that's an issue, but you know, we're pretty, I feel like the way we've kind of mitigated that is we've been pretty explicit about, hey, like calling it out really in the documentation. But there are a few, this is the part that I really can't get into. We know about it. There's definitely some stuff we've been thinking about, but I just can't go any further than that. But yeah, dangling subdomains is a pain. Like, yeah, and I'm not saying that just for like us. I'm saying in general, like when you allow people to point their DNS servers at you, and then however you do it, allow those subdomains to be, or domains rather, domains, subdomains, whatever, those TLDs to be pointed at, or domains to be pointed at you, and then yeah, you might have that issue. So
yeah, it's just kind of an interesting problem, right? Because on the one side, you know, helping these larger clients manage their presence, and they're pointing at, you know, AWS, GitHub Pages, you know, Azure, you know, all, you know, GCP. They're pointing at all these different services for different domains, have all of these different projects that are running. And then, you know, that group goes away, that project gets canceled, so they just delete it and they forget about the CNAME. Like that cleanup process is, I mean, it's difficult when you're managing thousands and thousands of domains, right? And that's where the bug bounty researchers, they come in and they're doing their subdomain brute forcing, and all of a sudden they find an AWS instance that is dangling in that case. So, you know, AWS is more difficult because you can't just claim the domain. You've got to actually, you know, pull out that, you know, ELB address that gets randomly generated. If you can get that same one, then you can take it over. Whereas some of the other services, it's quite easy, because if the CNAME's already pointed, but no one else has claimed it, you can just go in and claim it. So like it's this, yeah, like the responsibility is definitely on the client, right? It's on the customer. But I just wondered from like your perspective, like what else are you guys trying to do? Because I know from the whole repository takeover stuff that we talked about previously, like the code repository, that can be an issue as well. And so like it kind of fits in that same vein, at least in my head, as far as, hey, if you're able to actually prevent something, then maybe you can go about it. But obviously, if it's something like you can't talk too deeply on, it'd be interesting to go, you know, further down that road if and when something gets released.
No, and I think this brings up another valid point, which is the difference between I don't want this to sound like it's going to come off elitist or something. I don't know. Like, I don't mean it to be arrogant. What I mean is, it is the difference between an experienced, like really experienced, blue teamer and some of the, security researchers out there. Like, if you were to ask, I would bet if you were to ask a decent percentage of security researchers who are within that, and I think somebody posted a stat about the majority of bounty researchers being like with 1 to 5 years of experience, and like successful researchers, like 1 to 5 years of experience, which makes sense. They're building up a rep, getting some experience, et cetera, and they're going after it. I would bet if you were to ask them, that's like terrible, right? Oh my God. Yeah. You're expecting the client to catch that. What if how is that possible? Like, you should be, I don't know, we'll say calling out to these C names and seeing, what's landing like a response and what's not, and then reclaiming those or sending a notification or something, like basically saying the onus is on the service provider. But when you get to somebody with experience and understands the business aspect plus the architecture aspect, you start to get into this area where you're like, yeah, well, if we do certain things, then it's going to create a negative experience for your users, and then you have less users, or you're going to get complaints either way, right? People upset that you're letting them shoot themselves in the foot, and people upset that you're not. There's this lot of decisions that go into these types of things, and I think from a security perspective, it's like, oh, that's bad, you should fix that, and then it's like the reality hits in of, okay, well, those conversations may not go the way that you think that they will. So,
yeah. I don't think there's a good, like, I wasn't expecting a full-on answer that this is what GitHub is doing to prevent that, because I do see the onus on the clients in that case. You got to know what you're pushing and what your domain infrastructure looks like, your DNS records, where they're pointing to. I mean, that's kind of security 101 stuff, but it becomes hard, and it is a problem. The other thing that, like we've been talking to people about, is the fact that it's pretty easy as an organization to know what's in your DNS records, right? So there's no reason why you have to go out and run Sublister or something like that to figure out what's on your own domains. You go do a zone transfer, and you go and you check each of those domains. That's a pretty easy script to write or to run, to actually see, hey, is there any, are there any dangling C names or anything like that are out there? I've been tossing around, hey, maybe we should just go write something like that and post it up for, defenses to actually run, do a zone transfer, pull that data, run. Hey, it looks like this domain's pointing at AWS or GitHub or whatever dangerous, place, and you probably need to take a look at that. But
the funny thing is, when you say that, my immediate thought is, I bet Jerry Gamblin wrote something to do that.
Yeah, he's probably already got something like that. Especially, working on internal teams, that's definitely something that you should be looking at. So let's see. Kevin did bring up one point on the DNS DNS SSRF, or the DNS collaborator ping. And like, he's saying that the biggest benefit that he sees is that client user input is being fed somewhere down the app that leads to a DNS query. And I can definitely see that from a danger perspective. The issue so the biggest issue that I have with that is that Burp labels that as high severity, right? It comes back as a high severity finding inside of Burp. And from a risk perspective, I'm always like, okay, yes, there is some exfiltration there, but this isn't like a real like proof of concept that I've actually extracted some data outside of the host header or whatever has been passed in, and then a DNS lookup happened. So
yeah, it's hard. It's hard because you have to have.
It's hard to quantify. Yeah,
right. It is. It's like, what's the value in getting that to call out to your app? Like, that's really the important piece. Is it retrieving something? Is it sending some data? Like, is it going to do like I don't know, some sort of almost like a webhook event where it sends off some stuff you're not supposed to see? Yeah, it's very contextual. That's the word I'm looking for.
Yeah. Well, and that's always what it ends up being in my reports is like, hey, it looks like this happened. If I can do something else with it, that's great, right? If I can figure out how to feed the DNS somehow and do an SSRF lookup and then like export that back out, I'm golden. But most of the time it's just like, oh, there was a DNS ping and I know where in AWS your systems sit, right? Or at least one of your systems. Yeah. Anyway, so cool. So we've talked DNS SSRF, we've talked subdomain takeovers, and none of that was on our list. So
none of it. That's the thing. We're 33 minutes in, and we haven't even gotten to like the little AppSec minute we thought we might get into, which I think we can. But yeah, it's funny. This thing goes so quick every time.
Yeah. So you wanted to talk OAuth, right? Let's jump into that. Let's do the AppSec minute.
Yeah, because we were talking about what to discuss is like a little real brief knowledge dump, and I've been dealing with a lot around OAuth, and I figured it was worth discussing briefly the OAuth relationship, and then how that flow kind of works, and then why the state parameter is important. So just because it's an AppSec-y thing, and I've been looking at OAuth specs a lot recently. So OAuth. So you're like, I'm sure everyone's seen the sign in with GitHub, sign in with Facebook, whatever. So if you're doing single sign-on, there's usually two protocols you're going to use, OAuth and SAML. With OAuth, the way it works is that there's an OAuth provider and an OAuth client. The app that has the button that says sign in with, that's the client. And then the provider would be Facebook or GitHub, right? So if I want to sign in to GitHub, I click a button, initiate a request, and off I go to the provider where I enter my credentials. And then there's an exchange that occurs. Part of that exchange is you get a code back, or you give a code, you get an access grant. There's an access token that's given to you at the end, and you being the client, sorry. And that's how we say, like, this person's good. They initiated the request. They validated their credentials they validated their identity on the provider. They've come back. We've done the exchange to make sure that the communication validating this person between the client and the provider is secure and everyone's happy. So note to touch on there is I've seen some confusion around like what the state parameter is in that request, and all the state parameter is something that says this person meant to authorize this app to, we'll say, Twitter or GitHub or Facebook, whatever. They meant to initiate this request. And they meant to authorize this account to be linked, right? That's really all it is. Because you are probably going to give this OAuth client you are going to give this OAuth client a token, which then can be used to access Facebook data about you, whatever, GitHub, whatever it is. Okay, so we need to make sure that you meant to do that. So that's what the state parameter is. It's not validated on the server side. It's echoed back by the server, but the client's actually the one that goes and says, okay, I provided this this one-time use token that's got high entropy. I provided it off to the server. The server echoed it back along with the other details that tells me this is the person who initiated this request, and we're validating this transaction. And so the state parameter gets validated on the actual client side. And then there's another piece to that, which is validating. So that's like kind of like an anti-CSRF. Well, not kind of, I mean, that's an basically CSRF protection, right? Which I don't know if we want to get into it because this goes a little bit farther beyond the idea of a OAuth, but CSRF protection in general. There is a trend now to verify that, and it's a pretty good one, that the origin or the refer actually, and I think, I don't know if were you and I talking about this, like validating the origin of the refer header Seth, to as an anti-CSRF protection mechanism?
No, that wasn't with me. I'm not sure who you're talking to on it.
I forget who I was talking to. I think we were. Oh yeah, I'm not. I can't remember. Might have been someone else, or definitely was somebody else. But yeah, so like I think that there has in the past been a debate about like using and let me back up real quick. Like let's say you have your website like Seth.com, and in that website you've got like a I don't know, some JavaScript that immediately sends the user who visits your site off to initiate this, like, for example, OAuth flow or whatever the case is, or, you know, transfer some money or whatever the case is. That request that's initiating from Seth.com will have Seth.com in the origin or the refer header. And this is just because that's how the web works. That's how browsers work. Yeah. And even if you try to, like I've tried before to craft Ajax requests with JavaScript where I like modify those headers, that's outside the specs. It doesn't let you do that. So basically, like you want to say, hey, is there a refer origin header? And if so, is it what I expected? Did it originate from mysite.com or did it originate from anything else like Seth.com? And so people are using that more and more now when there's a case, and there certainly are cases where, you know, for instance, if you have an app that you visit and you're not authenticated, well, how do you do a nonce? I mean, who are you tying that to if you're not authenticated? And that scenario certainly exists. So that's sort of where that came from, that refer and origin.
That's interesting, because I mean, that was always the argument for CSRF, is whether or not that could be depended upon for CSRF protections, right? Hey, you're doing a post. Is it, you know, is it tied to that HTTP refer header or to the origin header? And, you know, if the protections, you know, back when CSRF protections came about, you could always rewrite that with some sort of an Ajax post, right? Or you may not be able to modify it, but at least you could add that header in as you wanted to, and maybe successfully, you know, bypass those protections. Hence the reason that they came up with the CSRF tokens instead. So it's interesting to me that OAuth is moving that direction, and it may just be based on the later clients. Now that's no longer something that Ajax is allowed to do.
Yeah, no, I mean, it's and this is where I can think that's sort of where the debates have occurred on its efficacy. Is, you know, expected behavior, past behavior, and current behavior. But you know, it's definitely something that, like I said, I mean, I would rather have, obviously I'd rather have a nonce. I'd rather have a high entropy, super unique, one-time use, hell, even tied to the path that you're making the request to. If those don't match up, boom, you're 401, 403, whatever. And that'd be great. That's fine. But there are just instances where, you know, what do you, how you have to tie that to an identity.
Site, yeah. Right? Yeah. How do you authenticate the site where that request is coming from? I mean, especially in the case of GitHub or Facebook or, you know, any of the large identity providers, like I just feel like there's so many options there. It's probably not something that they could pull from, right? They're going to have to identify on something else, or they just allow everyone, and it's up to you. Again, you're pushing the security to the client, right? But it's up to the client to recognize whether or not that's a place they actually want to go and authenticate and send those credentials to, or that information. So.
Yeah, man. I think I had sent out a tweet. I don't know, in the last week or two, I sent out a tweet saying something like, due to changing web standards, I'm sure I'll never be confident as an AppSec professional. And and I meant it because I'm like, things keep changing. And in fact, I'm following, just to keep up on things, I'm following the Web AppSec CSP repo. I just watch it just so I can see the changes that are occurring. And this is just for CSP, you know, and watching how things are changing. Like the standards are what makes, like, the server-side stuff, such as insecure direct object reference or SQL injection, you know, that's pretty pretty standard, pretty straightforward. You know, things somewhat change, and like I guess like when NoSQL was became a thing, like there was NoSQL injection, but in reality, like the standards that are changing are, you know, in the web, really in like the web standards themselves. And I know we were going to talk about HTTP too. I don't even think we'll get to it today, but you know, the web standards change, how browser behavior works or bugs that are introduced, and how that affects your client side, like headers that you provide for security or whatever like you're doing to implement security. That stuff changes, and then you know, various protocols change, like HTTP. You know, it's evolving. It's all so. Yeah, like keeping up with it, and like what was a problem and a protection yesterday may not be, or vice versa, you know, the thing that happens today. So it's, yeah, it's AppSec is hard. I think that's what I'm trying to say, people. AppSec is hard.
Yeah, it's a moving target, right? That's the whole issue, right? I mean, because you think back to the old days where like the site protections, like the site gates between like browsers, like allowing access from one site to another site. A lot of our security protections are built into that, right? But there was a time like back in the Netscape IE days when that didn't exist. It was very easy to actually call different sites and pull data back and actually view data from places that you shouldn't be able to get access to. But a lot of our protections are built on that concept. Somebody screws that up in a major version of one of these browsers, and that's a huge gaping flaw. And nobody, like on our side, people probably wouldn't catch that for a while, unless, you know, like Google and Firefox and everyone that's building those, unless they're running their unit tests to make sure that protection exists. We're very dependent on that. We don't do a lot of like client side testing from that perspective.
And it's actually a super good segue into the top 10, because the number 10 item on that top 10 2018 web hacking techniques released by Portswigger, item number 10 is, it's using very non-standard or a very non-traditional way of a browser to basically like monitor latency and you can basically create a timing attack.
Yeah. So. Well, yeah, let's jump into that then, right? Like, okay, so you know, we talked OAuth. If you've got other questions on that, feel free to ping us either on Slack or on Twitter or whatever. We're around. We can be found. Otherwise, Portswigger this last week, and it was actually James Kettle, I think, that released it and did the blog post on it. Released the top 10 web hacking techniques for 2019 or 2018. So they had all of their researchers and all the people they know submit like the different cool techniques and cool hacks that they saw in 2018 and pick the top 10. We'll talk about a couple of them that are interesting to us in the time that we have left today, but we will post up the link if you haven't seen it yet. Go through and read it all. There's a whole bunch of interesting new or different attack techniques that are built into that from a researcher perspective, from a defense perspective. You got to know about them. Okay. So we'll start with that number 10, right? The timing attack. You want to step through kind of what that one was, Ken?
Yeah. And I'm trying to, okay, there. I put the link on both channels, Slack and YouTube. Yeah, and for the record, if we get this wrong, it's because we had limited time to. We actually were like, well, screw it. We'll just tell people if we're going to give hot takes on briefly read and understood material. But I mean, it's not the most complicated thing in the world, right? It is cool, but and we've gotten a report in that had a similar behavior before, which I thought was pretty cool. And the basic gist is that like the example they show is creating latency in a request. So I think it was a CSV, it's the example they show is a link that generates CSV files. The more column more columns you add to that CSV generator, which you do by adding those columns via the HTTP parameters, the more latency you're going to introduce, because the longer it's going to take to generate that CSV. Now, the thing is, because of the way that the origin policy works, which is, Seth.com can't, shouldn't be able to see the responses generated from, say, like if you've initiated a request, you shouldn't see the response from Ken.com, right? So, however, what they've called, I think that's why it says XS search or something, cross-site search, basically initiating your browser to make a request off to a site and then evaluating based off the cache that Seth.com would have access to, evaluating how long the load time was for that response to Ken.com. So if you basically, Seth.com had me make a request off and I generated this large CSV file, which took a long time to load, you'd be able to inspect the cache to see if basically if there was some latency. And if I butchered that, my apologies, but from my understanding, that's the basic gist, is being able to.
It's definitely kind of like a binary, like timing-based attack against SSRF, right? From what I'm reading, right? Like it's cross-site search, so they're looking up whether or not bugs exist with specific paths, and then using the CSV generator and that like internal cache, because if it is cached, that bug exists and it takes a long time for the CSV to load, and they know that there's a problem with that specific, right? Like the specific path that they're searching for. Is that how you're reading it?
Yeah, it's just to basically do some enumeration on whether a resource exists, which would be, for instance, like if I don't know, you had like a private. Do not do this because this is not what I don't care. But let's say on GitHub.com, like you want to enumerate like an organization and a private repo name or something. That would be kind of like if you're like, oh, if I could find a private repo name, or I don't know, that's not really impactful, but I'm if I was more creative right now, I could think of a better, like, if you could enumerate that a location exists, especially if there's missing function level access control, where if you just know that route exists, like if it was, for example, some like forward slash, I don't know, some forward slash like invite with some random value, and then you can just guess that exists based off that. And then if that did exist, then you could navigate to it. I guess I don't know. It would be enumerating that something exists. And if missing function level access control came into play here, where there was no authorization on that resource, it might behoove you to know that existed and navigate to it, I think.
Yeah.
And again, if I'm butchering that, well, my bad.
No, I definitely think that's the basic premise, is that you're using that lookup function to actually determine what resources exist that you shouldn't have access to, or you shouldn't even know. You shouldn't even be able to enumerate whether or not like that private bug in this case, that it exists. But being able to enumerate that could potentially, lead to other attacks, just like you're saying, the access control issues or whatever else that could be there. Right?
Yeah, I mean, it's definitely, I think it's very interesting to use that latency to discover resources. Don't get me wrong. I think that's super useful, or super cool. Sorry.
And this is useful. I mean, and that actually hits on like user enumeration and timing attacks, those kind of vulnerabilities for like most web applications. We don't necessarily talk about that a lot on the AppSec side of things. I know it pops up every once in a while. You see SQL injection using timing attacks all the time. If you run SQL map or anything like that, it will use timing attacks to get data back out. But from an enumeration perspective, we don't really dive too deeply into that. And I wonder if there's more research to be had on that side, as far as, hey, guess what? We do know that these accounts exist, and it takes 500 milliseconds to get like back a password invalid or whatever error message versus the other one. I feel like there's more things that you could do with that, because most developers don't do any sort of timing games with it when it comes to responses, because they usually don't think about it. And usually it's not a problem, because if you've only got 500 users, that timing is just so inconsequential. I still can't talk either.
It's just hot takes and gibberish.
Yeah. It's inconsequential in the case of a small application, but the second that you get to be a large application, it can turn into a full-blown attack, and it may be easier than people expect. Anyway.
Yeah, I mean, and I'll tell you, and by the way, I was thinking we'll probably just get to this next one, number 9, and then I'm thinking maybe, I don't know how you feel about this, but maybe 1 through 8 we cover as the one each week as AppSec minute going forward until we've completed all of them.
Yeah, that works. Yep.
So for number 9, the one I don't really need to even look too deeply at this one, because I've seen this before and I thought it, and it's really like super cool. So the number 9, let me read the title: data exfiltration via formula injection. So like if you've ever had the displeasure of working on spreadsheets, such as myself, I know you've done a lot of spreadsheeting, Seth, you know that you can create formulas to like calculate numbers. Like if I wanted to say rows 1 through 5, when they're totaled, equals some number, maybe row number 6 would be the sum total. That's a formula, the sum total of those first 5 rows. Cool. That's a basic formula. Those formulas can get super advanced. And that's kind of the point here, is that, like, let's say you were able to inject content into a CSV that's being generated. So let's say I am able to inject content that's going to be CSV you open, right? So let's say I'm able to inject a formula that then makes calls out from your machine to mine when you open that Excel spreadsheet, or I think it was in this case Google spreadsheets, or
Google Sheets. Yep.
Library. I don't know how you say it. Whatever. I don't use Open Office, so I don't know how to say it. But anyways, yeah. So that's the basic gist. Is if a website's generating CSVs and I can get you to download a CSV, or get you to open up a CSV with one of those programs that I've controlled the content of, and I use a formula to make that call out, and you download it and you execute it and it makes a call out from your machine, cool, I've won as the attacker.
No, that's I mean, that's pretty clever. Like abuse cases from within CSV generation. Oh, Ken, you're muted. Okay. Yeah, you knew you were. Okay.
Sorry. Yeah. I didn't want you to have to hear me sipping on Diet Mountain Dew.
No, you're fine. Yeah. Like I'm looking through it now, right? I don't know how many times I've actually seen CSV uploads, because it's in a lot of applications. And you wonder how that's actually, like, what that's being opened into. Most .NET applications are probably opening that straight into Excel. I'm sure they disable macros in most cases, but those formulas that are embedded into each of those cells, I don't know if they actually would, right?
Right.
I mean, I know the payloads, like the Etsy password payload, that gets interesting, but most likely people aren't going to be opening that on like Open Office. Yes, like it's just not as common as some of the others, right? But
right. Although I will say this, if you were to open it in Google Spreadsheets and like export it into a format for, like, let's say Word or something, or Open Office, like, cool. Yeah. Like you're good. You've done it. So and that's the example they show for context. What Seth just said was they show reading the contents of that cat, I think, or reading the contents of Etsy password, and then sending that content out to the attacker-owned server and seeing that in the request.
Yep.
Like it's literally a GET request with the entire as the path, the entire password file as the path part of that request to your server. So you can see that in your logs.
Sure. Why not? Right.
Why not?
Like, you know, it really comes down to, yeah, it is. It's pretty clever, right? To actually send that along in that way. I mean, a lot of times we forget that all of these, like all this middleware that we use in between, like we're building this application, that all this functionality exists. I mean, this is very similar to some sort of like local file include vulnerability, right? You're basically including the file in that exfiltration, and then you're sending it off to a third party somehow. Yeah, it's pretty. That one's pretty clever, right? Like I've already
seen that one before.
That I can test, right? Yeah, you've seen it before.
Oh yeah. That's not my first time seeing this before. Like I've seen. I don't remember when, but I dealt with this a year or two ago, so it's definitely not new. Well, sorry, that sounds bad. I'm not saying like it's definitely novel and it's cool and it's awesome, but this is not the first time I've come across it. So when which is I think maybe the point of the post, you know, of this post is that these are sort of the things that are becoming cool, common. They're novel. So yeah, like but this is not my first rodeo with this particular vuln.
Yeah, that one's not one. Yeah. Yeah, like I'm looking at those payloads. Like those are definitely going to be on my next. Like, hey, I found a file upload system, and it takes CSVs. Let's see what happens when we give it something that is, you know, formula based rather than just cross-site scripting based, right? Or SQL injection based. There's probably some more interesting things there that we can run through that are, yeah, that could be exposed. So sweet. No, that's definitely a good one. The other top 10 that we've got in there that like, so next week we'll talk about Prepare, the XXE, some of those others. I know that James, he's talking about that web cache poisoning again. That's number 2. I think we've reviewed that in the past when James came out with that, the way to poison web caches.
Right.
It probably would be good to talk through it again.
You know what? I'll send him an invite to come on the show, see if he wants to do it. I've met him several times. The last time I saw him was at the HackerOne GitHub event. HackerOne did like 5 nights of different companies or different organizations. We were one of them. And anyways, that was the last time I talked to him in person. So I'll send him a note and see if he wants to jump on the podcast. So you can talk through some of the stuff. So
yeah, the more that we could get, somebody that's an actual expert, right? That's good.
You know, the person that put all this data out,
blog post and put it all out. Yeah, it'd be fun to talk with him about it, right? Let's see what else. I think next week, do we have? I don't even have the list up in front of me.
Yeah, sorry, I'm trying to pull it up too. So next week is Eric from Security Compass, followed by Jessica Ryan. The week after that from Trusted Sec. I'm super excited because on April 2nd, my boss actually is coming on, which I've asked him to come on more than once, but we kept like the timing was just a timing thing. But I wanted him to come on because he's been with GitHub for over 5 years and he's seen it grow from like the company and then the security team. He's grown and the initiatives have grown. And I just think it's super helpful for those that are building security programs to hear his story. And I don't know, that one I almost feel like is probably gonna be like an 1.5 hour long episode. It's gonna be, yeah, if I could, I would make that a 3-hour one and we just sit around, but it's going to be a good one. And then let's see and we are talking now with we talked to Zoe from OWASP about women in AppSec and their various initiatives. So we're going to have a group of folks who are working on those initiatives join the podcast. We're just figuring out dates and times. So, I mean, Seth, we're busy. We've got a good couple months coming up here. So, stay tuned.
Do. Yeah, and I know Eric at Security Compass is going to want to talk training stuff, right? Like kind of the just-in-time training that those guys provide. I know with Sean, like we were kind of talking about that in the past with Sean Porras and like the management of their program over there at Verizon Media. So it should be interesting to hear that other side on how they're trying to provide that. I know that's part of the reason Eric wanted to come on was to talk through it. So, the developer training aspect and how you get developers trained when they need to be rather than waiting and, trying to cycle them through once a year. Their approach is novel in that perspective. And then Jessica Ryan, like I've met her multiple times, her and Gabe, they, kind of do the circuit. They were in New York for a while, but now they're at Trusted Sec. I think Gabe's at Mandiant I think he is at Mandiant now. But they've both been on the like the security training circuit for a while as well, like teaching at conferences. But she just started at Trusted Sec doing web application security. I thought it'd be interesting to hear her perspective. So yeah, it'll be fun. And then I'm excited to, your boss will be good. Greg will be good. And get a different, somebody else's management perspective on how they run a program and they build it from basically 2 people to an enterprise class program. That's going to be the interesting thing, right? Is how you focus in on what's important and prioritization, because we see so many organizations that struggle with that.
Yeah, and Greg is it's interesting because he always has like a it's like, you ever met someone where you're like, oh, you think like you have a pretty good, like you think you have like the answer and it's pretty straightforward on when you make a decision, like what, but then like someone comes in and they think of kind of something completely unique. That happens a lot with Greg. He's got a very unique thought process. He's really creative at coming up with like good solutions for things. And yeah, I can't say enough good things about him. And it's not just because he's my boss, which, by the way, I say that because he hates it. I could tell he always hates it when I say that.
When our performance reviews again, like what are we doing here?
Yeah, no, I only say it because I know it makes him like, but anyway, so I'll just keep using it. Keep saying that. Anyways, but yeah, I'm excited to have all these folks on. So yeah, we got some good couple months coming up. I'm excited. Yeah. And that was a nice way to wake up yesterday to find out that we're going to Tel Aviv to do the training. I'm very excited about that.
Yeah. Now we just have to figure out travel and all the other stuff that goes along with that, right?
Yeah.
Good. Let's see. I think that about does it for us today. Find us on Twitter, or come to Tel Aviv. That's kind of the next place we'll be. I guess Ken will be at Locomoco Sec. I won't be this time around. There's just other stuff going on. So that I won't be able to make that one, but we'll be having the podcast every week. So feel free to reach out, find us on Twitter, come join Absolute AppSec Slack channel. And yeah, it's great to talk as usual. And thanks for the hot take, Ken.
Same to you.
And the gibberish.
Yeah.
Gibberish and hot takes. That's how I'll label this one. So I'll rip the episode and get it up within the next, by tonight, so everybody else can get it. So find it in the usual places.
Thanks, everyone.
All right,
appreciate it.